Hello and welcome to Locav-howto, your hub for Geospatial data analytics. In today's video, I want to teach you how to generate random geospatial data for experimental analysis. Please take note, this methodology is mainly for experimental purposes, for research purposes. Don't use it for real-life problem solving. So the data set we want to generate is for wind data sets, within Nigerian boundary. So we want to generate random features, point features within Nigerian boundary, and to extract the coordinates and populate within the attribute table, and to generate wind direction. So the wind direction will range between 0 and 360, since we understand that direction range between 0 and 360. And also the wind speed of Nigeria range between 2 and 10, and so the data we will generate in this field will range between 2 and 10, and it will be floating numbers. I will also teach you how to generate random dates, so that we hold the date of capture of each of those points, and it will range within a specific period. I'll also teach you how to generate validation status data, which is binary codes. I will demonstrate how to generate binary codes that will be zeros and one to hold that record. So it's very important way to generate data. Sometimes you are, as a student, you are badly in need of data set and you can't find it, and all you want to do is to demonstrate to your lecturer that you can do it. So it will really help you to guide you on how to generate your data set. So why don't we go straight to the practical demonstration. So the data set used for this map, for generating this wind map, are derived randomly from scratch. Let's take a look at the attribute table. So let's take a look. As you can see, these are the attributes of the data: the wind direction, about 500 data sets, the wind direction, wind speed, date of capture, the wind speed categories. All these were derived from scratch randomly, and like I mentioned, this is something that can come handy when you are in their need of data sets and you do not have. So just pay attention and let's walk you through. So let's launch a brand new map. So this is an empty map. There is no data sets. We will create a set of data similar to the one I just showed you now. So the first thing we'll do is to create the points. We'll generate points, and the points, we will use a tool called create random points. The output name, I want to call it wind. So it's wind data set. It's asking the geographic area where I want to create the points. So if I had a map, maybe a map of Nigeria, I would have simply just select it. But because I don't have it, it has also gone ahead to provide us with other options. So if you want to create the points to intersect with other set of points, you can choose this and then create the points and then intersect it. If you want it to be generated on a line, you choose this, but in this case we want to generate inside a polygon, and so we will define the boundaries, the number of points, not the number of polygons, 500 points, units. This is the tolerance level. I don't want it to create anything outside of the boundary, so I'm giving it a 0 tolerance. Then it has served me with different tools. So this drawing tool, I'll pick the lasso, the freehand sketch, that will help me go through the boundary lines. Please take note, it does not require high accuracy. So I'm just going through the boundary lines. So I just want points to be created within this geographic regions, and I also set that the tolerance level should be 0. It shouldn't go outside of the boundary. So we have our polygon that we'll use to define, and after that the next thing is just to run the tool. So what is it asking? The name containing invalid character. Oh, it's saying the wind output features. So wind data. So let's see. Okay, I was surprised because it's supposed to accept it. All right, so this is the data set we need, and we don't need this polygon data anymore. So let's inspect the attribute table of the data. You can see we have 500 data set. So I will generate the wind direction data. So I'll go straight to calculate. I'll give it a name. And then the type of data, I can choose float, and then I will use random to generate the data set. Random will simply give us numbers between 0s and 1, floating numbers between 0s and 1. Yeah, as you can see, but what we need are numbers between 0 and 360. So what we'll do, we will multiply these numbers generated by 360, and that will raise each of them to, and I also would like to round it to the nearest 2 places of decimal. So let's run it. So this is simply how to generate random data between 0 and any number. The next is to generate random data between 2. So we will be generating numbers between 2 and 10 to mimic numbers, wind data sets within Nigeria. So wind data set, let's just see the range of data of wind speed data in Nigeria. Is already out for me, and it range between 2 and 9.5. So we will generate our data set to range between 2 and 9.5. So I'll go straight to say calculate. Once again, I will still choose I'll still write wind speed, and then it will request for data type. The data type here will keep it as float as well, and then let us quickly initialize. So we have, like I said, the wind data set for Nigeria range between 2 and 9. So we will give we'll create 2 variables to hold. This is 2. So the minimum wind speed is 2, and the maximum wind speed is 9.5. And so the range or wind speed range equals to this minus the minimum wind speed. So this range will give you a value of 7.5. So let's just use a console to see what range is. It's a simple fact, but so the wind speed range, let's just see. So it's 7.5. So if we multiply range, I mean a random by the range, it will give us numbers between 0 and 7.5. And that is not what we want. We want numbers between 2.5 and 9. So let's see, what did we call it? Wind speed. So let's see exactly what I'm talking about. So these are numbers between 0. So it has already defeated the aim. That's not what we want, 0s and 7. Let us go back. So what we want, what we should do is to rather do this and add it to 2. This will move everything, the minimum to 2, and then the maximum will move to 9, because 2 plus 0 is 2, and then 2 plus 7.5 will give 9.5, which is the maximum. So when we do this, we will get it, but we will also round it. No, it's not geometry. We'll also round our data to the nearest. We'll round it. So use the round function to round it to the nearest one place of decimal. So very simple. These are the wind data sets. Let's see the minimum. So it's giving us 2, the minimum, and the maximum 9.5. So this, we have achieved what we want. So next we will generate date of capture of the data set, and then we will also generate categories of wind speed. So we will go straight to generate the categories of wind speed. We will categorize the speeds where it falls between 0 and 3. We'll categorize it as low. Where it falls between 3 and 6, we'll categorize it as moderate. And where it falls between 6 and 10, we'll categorize it as high speed. So we will still give it a name and say wind category. Wind category. And the data type, will make it as text. So we will rely on the wind speed. So we will give it create a variable and store the wind speed. So wind speed is this, and then we'll use the when logical statements to categorize it, which is an alternative for the if, a better alternative when you are working with a huge set of data and want to categorize much. So we'll say when wind speed is greater than or equal to 3, it should store it as low speed, and then you use comma when wind speed is so it should be less than, rather than or equal to 3. When wind speed is greater than 3, and so we use and the wind speed is less than or equal to 6, we will categorize it as a moderate speed. And when is wave speed is greater than 6 and wind speed is less than or equals to 10, you should categorize it as high speed. And if it is out of this, if it is not within this, it should be categorized. We can just give it out of range. So let's test our formula. Right. So we gave it a name, wind category. All right, so let's see. Yeah, high speed, moderate speed, yeah, and low speed. So we have achieved our aim. The next, we will generate binary codes to define whether the data set have been validated or not on field. And so we'll also create. Okay, so let's give it a name yet and call it validation status. The data type this time around, we'll also give it the data type of text, right? Just like before. We will also create random set of data, but this random set of data we will round it. We'll round it to 0 place of decimal. So let's store this as a variable and let's see. So let's use console to view this. So we are expected to see zeros and ones only, either 0 or 1. And let us see what we are going to see. So this is 1. So that is what we want. Now we will use an if statement. If round is equals to 1, it should be stored as what? Validated. So this is a method that will teach you how to generate binary codes, zeros and one, yes, no, true, false data sets. So pay attention. So, and if it is not 1, which will definitely be 0, we will give it we'll call it not validated. So let's see. So that is it. Let's check the name again, validation status, everything is fine. Yeah, so you can see validated, not validated. So you can see how easy it is. And finally, we will generate dates. The dates will fall within 2024. So I'll say date of capture. Date of capture, let's take a look and pick the date type. So we will generate the dates of capture. In doing that, we will initialize, we'll provide the initial date, init date, and okay, so we have two variables. The initial date will be a date. We use a date function to hold the initial date, which is 2024, comma 00, comma 01. So the month for date in ArcGIS expression is a 0 base, so we start counting from 00. I will prove that to you very soon. And the last date is 11 here. You have to use 11 to depict December, so 31st. Let's use console to check for what the init date is. So you can see January 1, 2024. Let's use console to check what the end date is, 31st December 2024. So we will still apply the random function, but this time around we're applying it on date. We usually generate a range of data sets, then we multiply with the random. In this case, we will have to generate a range of data. To generate a range of dates, we will use a function, a date function called date difference. DateDiff. So date difference will take up the maximum, and there is the end date, comma, the initial date, and the unit. The unit is either day, time, and the year, month, but in this case we want to know the number of days. So this is a date difference. So let's call it a var date span. So this is just like range. So we have the span of dates, the days between January and December 2024. But we need to know the actual dates. This is days. So let's just use console to see what we get here. What we'll get here will be numbers and not dates. So we need to apply these numbers to a formula again. So you can see 365. So if we multiply this date span by random, so we will be able to generate random dates. So if we use random multiply by the date span, will simply give us random days. So let's still save it here as var random days and use console to check it. So let's see what is there. It's saying it has already picked out a date, right? So now we have a set of random numbers generated here, but there is a number called, there is a function called DateAdd that will take up the initial date, add it to a number of days, and it will give you a date. So that usually take the initial date, which is this, we have already set earlier, and we'll add it to the random days, and then we will also provide the unit, which is also days. What we are adding, this means what we are adding to the initial date, the unit is days. Okay, so it requires so this will give us what we want. Let us go. We provided the date of capture and everything. So let's see. So we have a range of dates between, so let's see the beginning, 01/01/2024 and 30th of December 2024. So it's as simple as this. We have every detail that we intended to create. This is the wind direction, this is the wind speed, this is the category of the speeds, this is the validation status, and this is date. So all these dates, as you can see, it's amazing to see that we are able to generate all these. And what is even most interesting is the features themselves. So let's try to symbolize it to make it look like what we saw here. At least we are talking about wind data set, so let's not just make it look dull. So let's symbolize it. This is just an extra to our work. The work is already done. So we are symbolizing it using a unique, and then we want to use the validation, the wind category, and then we will come here and format all symbols. We will choose arrow. We'll choose arrow, and this is the arrow we will choose. We can see all of them are focusing in one direction. We want to show that the wind data, the direction, wind direction, is actually directions. So we'll choose the wind direction here, and you can see all our data sets, they are depicting the actual direction. Next, we will symbolize. So we had the categories, the high speed, low speed, moderate. We know that high speeds will definitely we use a red to depict high, and low we can use green, and moderate we can use amber. Yeah, so we are almost done. Then we will also use size, also symbolize with size, to also use wind speed to depict size. In this case, we can reduce this to 25 and this to something like 8. Okay, let me just use 30 and 8. So this is exactly what we mean. You can see anyone with a larger arrow depicts wind speeds, higher wind speed at that location, and this is showing something around southwest direction. This is showing about northeast direction, and then this is a tiny wind showing at this point collected a wind that is the wind speed is quite low. To even make it more visually appealing, I would like my street night base map. So this is what we just done, and like I mentioned earlier, it's simple to follow. Just pay attention and you'll be able to get it. For the students who want to simulate data to prove points to their lecturers that they can do it, this is for you. And thank you very much, and don't forget to like, share and subscribe to our channel, and also continue to visit us for more intuitive, informative videos. Thank you very much.